Alrighty, folks, welcome to Q4 Enrichment Week. Those of you who've been around a minute know that we do this after most cohorts where we invite teams in to do guided workshop type sessions on topics that we really don't cover, but that we think are very important. And even though the overwhelming minority of people in our cohorts are not in the US, we are respecting the US holiday of stealing land and celebrating with eating turkey once a year this week on Thanksgiving. So we're going to do a 3-day rip on security, which is obviously super important, but also a very emerging sector in the industry. Today we have Cantina here. Met with Harry and Samara probably about a month ago and wanted to get y'all in. And Cantina is a super cool platform, for lack of a better word. That's probably the best word, actually, for getting involved with security. And I feel like what we've lined up for you these next couple of days is kind of a upward tier towards, what it would look like if you are working for OtterSec versus when you're getting started and want to really do this and do it a little freelance and bounty oriented, which is what Cantina is going to talk to you about today. So I will turn it over to the Cantina team, and thanks y'all for being here.
Hey everyone, so I'll do a little intro for Zigtur. I'm Samara, I work over at Spearbit and Cantina, but Zigtur is one of our best researchers. So we do like a mix of audits, competitions, bounties, and he basically came in, I think at the beginning of this year, Zigtur, February sometime. And just like there was a couple of speed bumps at the beginning, but after that, he's like top of the leaderboards, just absolutely smashing it. So I couldn't think of anyone better to kind of talk through security for Solana. So I'll hand it over to him now.
Okay, so hi everyone. So today we are going to talk about security in Solana, which is a really hot topic. So I should present myself a little bit. So I'm a security researcher at Cantina and Spearbit. I'm also a Rust instructor at Rare Skills. So basically I built the Rust bootcamp about security. And I'm currently second all-time in Cantina. And I want to thank Sujit Somraj, who helped me building this presentation today. So today we are going to see, we are going to talk about Solana security. First, we will do some recall about the Solana virtual machine, because it is really specific. And a lot of vulnerabilities are coming from the way Solana works. So if you don't understand how the virtual machine is working, you are likely to not understand any security issues, and you will build code with a lot of issues, I guess. So once we will understand the Solana VM, we could go through common vulnerabilities that are in native Solana, that are made because native Solana is pretty hard to handle. And if you have a missing check somewhere, you can basically break all your code due to that. And we will see that Anchor framework has been built to answer to this type of vulnerabilities in Solana. So it helps building better code with a lot of checks that are embedded. And we will go through a lot of these checks. Then we will talk about the edge cases of Anchor, because as it is an hardened framework, sometimes it is a bit too hardened, and so you can have issues due to that. We will go then through general advices to build secure programs. And so, in this previous part, we will focus mainly on issues that are related to the Solana virtual machine. Then we are going to see other security issues that can be related directly to the Rust language or to business logic that is not well handled. And finally, we will go through real-world hacks that happen and made a lot of noise. So let's talk about the Solana VM. So that should be some recall for you. On Solana, all the data are stored in accounts. Like you can think about everything is an account. And when you store data, you need to pay a rent. And if you want it to be rent exempt, you will have to pay to deposit something that you will be able to retrieve when you close that account. So the more data you have to store, the more you have to pay. And an important thing is that every account has an owner, which is a program. By default, this is the system program. So when you build a wallet, it will be owned by the system program, which is the default one. So what is an account? It's a simple structure in which you have data, which can be null and can be up to 10 megabytes. It also has a Boolean indicating if it is executable or not. So it will be true if it's a program. The lemports field is about the account balance. And finally, the owner that I was talking about just before. So if we look at a simple wallet, it will have a balance, which is lemports, and it's owned by the system program, which is the default one. It is not executable, and it does not store any data, so it will not have to pay any rent for it. Then there is a program accounts, because when you build a program, your code will be stored in the data of an account, and it will be this account will be owned by the BPF loader. So the BPF loader is like the program that allows to execute other programs. Why BPF? BPF is like like a virtual machine. It is used in the Linux kernel, for example. So you may know WebAssembly, which is well more known, but Solana has made the choice to use BPF. And so we can see that for a program, it will be marked as executable. And so, yeah, after all program can just own other accounts to store data. This is really useful, and we see it everywhere for accounts and for PDA. So here we come to PDA. A program-derived address is just an account that has an address, not a public key, an address. And this address is not on the elliptic curve, so there is no public key attached to it. And it is deterministically derived from the program ID, such that if I have a program and I write to a PDA, I am the only one able to do it because other accounts will not be able, other programs will not be able to write to it, and this is a good thing. So this is how we handle like hash map in Solana, and it's an interesting feature because it also enables for program signing. So when your program should call another program, we see it a lot on multi-sig wallets such as squads. So program derived address are a really important concept. So if we summarize everything, we have our user that has a public key, a secret key, and so the wallet by default will be owned by the system program, and a wallet will not have any data. So after that, we can call a program that is owned by the BPF loader, and this program will own and write to PDA or accounts. At first, the account is not owned by the program, it is owned by the system program, and you will have to initialize the account and change the ownership to the program that will own this data. If you have any questions, don't hesitate to interrupt me. So when we are calling a program, we are passing some instruction data, saying which program are we calling. This is the program address. We put some accounts, a list of accounts that will be used by the Solana VM and the program to read or write the data. And there is the instruction data, which basically allows you to select the function that you want in the program and pass any data that is needed, such as an amount or something else. And so every account has specific fields. This is handled by the Solana VM, and it will check it for you. So, for example, when the user makes a transaction, and so he is a signer, and the Boolean signer will just be set to true because he has signed the transaction, and this is checked by the Solana VM. So yeah. So this is a basic native Rust example. That was what I was saying about when you have the instruction data coming in, you need to dispatch based on this data to which function you should call. So in this case, there is only one function, which is the process initialize. And so we are expecting an instruction that is initialized. If it's not, it will just fail at this point, and the code will just fail. Okay, so we are going to see some common vulnerabilities in native Rust. If you want to follow, I post in the chat a gist that the code is available here. So when I was saying before that, if I go back, that there is these fields, in fact, there is a little bit more than that. There is all these accounts info. So for every account, there is this type of data. And so, as I said before, we can find back the owner of the account that is passed. And this owner is really important to check, because if I want my program to read its data, I will have to check that the account that is passed is owned by my program and not any other. If it's not, it can lead to severe issues. For example, we can go through a breaking access control. So this is a simple instruction that creates a user. So we can see that we just iterate through the accounts that are passed. The first account is the admin account. And so we are likely to check this account because only the admin should be able to create users. Then we decode we expect the user account. And then we are expecting the signer so this will be the admin. And if we look at the admin data, we are just decoding the admin account data, but we are not, so directly we are checking that the signer is the admin in the data of the admin account. But we are not checking that the admin account is owned by the current program. So that means that any user can create its own admin account-like account and pass the data he wants in it. And as the owner is not checked, it will be bad. So the fix in this case is just to check that the admin account owner, so the owner of this specific account, is the current program ID we are executing in. Any question on that? Okay, should be good. So after that, we have the isSigner Boolean, which is really important. It indicates if the account is a sort of caller or authorized the check, the call. So this issue can appear when you have like a role restricted functionality, for example, access control, or when you have user specific operations. So if Alice makes a token transfer, she has to sign it, and Bob can't execute a token transfer on Alice's behalf without her approval, so her signing the transaction, except in the SPL, but it's not important here. So we are going through another issue, which is a vulnerable access control once again, because it's pretty easy to find what is going wrong. So just as before, we have the account iterator, and we are decoding the data account and the signer. And in this case, we are correctly checking that the data account owner is the program ID. So we can trust this data because it is owned by this program. And then we are just decoding the data and checking that if the signer is the expected admin, then if it's not, we are going to send back an error. And if it is, we are just going to store data. But in this case, we are not checking that the signer account is really a signer. And so what is missing in this specific code is to check that isSigner is not false. Because if it's false, it means that it does not have, it did not provide authorization for it. So basically, this means anyone can call it and break the access control in this case. And one other issue that is particularly interesting in native Solana is the account confusion. So every account can store data, and it is encoded in this data field. But the thing is that when you have two accounts that have similar layouts, the deserialization will not be able to say to handle the case. Like it can't fail if it's exactly the similar layout. So for example, here we have an admin structure, which has an admin pub key and a timestamp. And after that, we have a structure with a user and so it's pub key and an amount. And so in these two cases, we can see that it's a pub key and then followed by a uint 64. So the program will not be able to differentiate both. So you will be able to use a user structure as an admin structure, which is pretty bad. And so a way to fix the issue is to use different layouts so that both fails, or it's to use a discriminator indicating which type is your account. So for example, you can set just the value 1 for the admin and the value 2 for the user, and then you are going to check if it's 1 when the admin is expected. So basically about native Solana, developing in native Solana, it requires a lot of checks. And it also requires a deep knowledge of the SVM, of the Solana VM. And these type of issues are pretty hard to not to find, but to think about, because you are doing so much check that at some point you will just do a mistake, and this can just mess up everything in your protocol. And this is why the Anchor framework has been built. It is really powerful because all the redundant checks that I was talking about before, they are all abstracted from the user, from the developer. Like he doesn't have to handle the serialization and deserialization, initialization of the accounts, the rent payment. Like it's really easy to use. And so yeah, it has a lot of security checks in it. So it's checking ownership, PDA derivation, a lot of things. But what it really does, Anchor, is just generating the code through Rust macros. So you can use your Anchor program and then run the macro, expand them. And so you can see your native Rust program that has been built with Anchor. And this is really interesting when you don't really know what Anchor is doing behind the scene. And so I really recommend to use the cargo expand tool because it will just expand all the macro from Anchor, and then you are able to see every checks that are done behind the scene. This is pretty hard to follow in the documentation of Anchor, to be honest. Like it says something, but it's not always easy to really know what is going on. So this is a good way to do it. And right now we are going through an example of the macro. So I'm sending the link. Anchor expand. Oh yeah, I didn't try Anchor expand. So yeah. So we are going to study this small contract, which has just two simple instructions: initialize and create user, in which there is admin access control for the create user, and initialize just set this admin. So when you are seeing signer here, what is going on behind the scene so you are putting the signer structure here, and Anchor behind the scene will check that the is signer boolean is set to true. If it's not, it will return an error. So this is really nice to abstract, to not make mistakes that could have been done before with the native Rust. Yeah, it also do ownership checks. So when you are building your own structures, you are using the account macro. Yeah, someone is asking a question. D1? No.
You're mute, maybe D1.
Okay, it's maybe a mistake. So yeah, when you are building your own accounts with a structure, you can use the account derivation, the account macro, and this behind the scene will do a lot of things, and then you can use it for input accounts to your instructions. So it will implement the owner tray, which will be generated automatically. And what is going on once again is that every time try account is called, try account is just the way Anchor decodes all the accounts that are passed to your instruction. Then it will check that the owner of the account passed is the expected crate ID. So is the expected owner setting crate ID. So this is why in Anchor you will see the declare ID with the public key of your program. And to avoid the account confusion that we have seen before, there is the discriminator that has been set and is really well known on Anchor. So just like before, the account macro will generate the discriminator automatically. And what is going on behind the scene is that every time we decode an account, we will check that the 8 first bytes are the expected discriminator. This value is built on based on the name of the account of the structure that you are using. So, for example, we were talking about the admin structure. So this is a hash, part of the hash of the admin word. And so, yeah, so Anchor does a lot of things. It does signer check, ownership checks, and many more. And so, yeah, when you want to know how Anchor works, looking at the docs, at the documentation is pretty cool. But the thing is that you may be limited by this. And so if you want to be certain to understand what is going on, I would recommend you to look at the code because the documentation is not always enough. And yeah, Anchor, it facilitates and makes easy and secure the integration with a lot of native programs. So you can use it for account initialization, token and token 22, a lot of interactions. And so do not hesitate to use this type of external integration because it really, you are not likely to make mistake by using them, but you need to still understand what is going on behind the scene. And so now we are going through the edge cases of Encore. So Encore is really cool because it helps you harden your code and make it secure. But sometimes it may be a little bit too much. So most of you should know the init macro. It ensures that an account is initialized only once. This is used, for example, for program initialization when you are setting some data once your program is deployed. But when you are expecting an operation to be done multiple times, then you will not have to use the init macro because it will fail if the account already exists. So yeah, that's what I was talking about. For one-time operations, the init macro is really important to use, and it can break when it integrates with a lot of repeated operations. So, for example, or when you don't expect it to be already initialized. This is an issue when you are integrating with a token account that is an associated token account, because everyone can initialize the associated token account. This is a great feature coming from the SPL, the Solana Program Library. But yeah, if you use the init macro with an ATA, you will go through some issues. So this issue is an interesting one. So basically, it was what I was talking about. It was found in the OLAS competition on Cantina. So OLAS is a project that is like cross-chain. I can send the. Yeah, we should use init if needed. This is it. So yeah, this was one of the issue. In this case, we are expecting a token account, which is named PDA position account. And we expect it to be the associated token account not owned, but on which the lockbox has authority. And the mint is this one, the position mint. And we are using init. And so if we use init in this case, it will just fail if the account already exists. So that means that if I'm a malicious user, I'm an attacker, I can just call directly the associated token account program and initialize this specific token account. And then the user that wants to just do a deposit, he will just not be able to do it because the account is already initialized. So someone was saying it in the chat. The way to fix this issue is to use the init if needed macro. It's not by default in Encore. You will have to import it by using the init if needed feature. And so we understand why it's protected like that. Init if needed should really be used in specific cases. Because if you put an init if needed on an admin, on an initialization, for example, a program initializator, then you are going to have, you will have multiple initialization possible, and this can lead to just breaking your whole program. Yeah, this one is interesting too. So you remember about the account confusion. This issue is pretty much the same. It's like it's a sort of account confusion, but when you expect two accounts of the same type, an attacker may pass 2 times the same account. So it will check all the discriminator and things like that. Because yeah, it can be confused, but when you have twice the same account, you should check that it's not the same if you don't expect it to be the same. And so yeah, for example, here we are expecting 2 user accounts, user A and user B, on a transfer instruction. And so user A should not be able to do a transfer to itself in this specific case, for example. And so you should ensure that user A is not the same as user B. So in this case, you would have to add a constraint to be sure that they are separated accounts. There was an interesting issue that was with this type of root cause. It was on Sherlock, and I can't remember the name of the contest. But and finally, so you may know the unchecked account structure in Anchor. This can be useful in certain cases because you can just get rid of all the checks that are done by Anchor. Not that you will have to add this specific comment, or Anchor will not compile your code because it wants you to be aware of what you are doing. And so in most cases, you should not use this unchecked account because it's unchecked, so it's unsecure. Okay, so to summarize it, I would recommend you to always use Anchor, except if you have specific needs. So for example, you need to have a really optimized program. In this case, you would have to go in native Solana, and so you would have to be really confident about your skills and maybe go through an audit to be sure. You should be aware also that Anchor is not perfect. We have seen in the past multiple issues in it. I remember that at some point you could just use the Anchor, like the associated token constraints. We're just expecting it to be used with the token program. And if you were using the token 22 program, it was just not working at all. So you should be aware that it's not perfect and you may go through some issues with it. And to build a secure contract, a secure program, I will highly recommend you to harden a lot your constraints to be sure that you can't even restrict even more your constraints, and then going through a lot of tests to be sure that your constraints are good. Because when you have well-hardened constraints on your accounts, this really rise up the level of security for your code base. So I will, if you should really constrain all the account that you are passing to your instructions. So we have been mostly talking about the issue related to the Solana virtual machine with the Anchor, but you may have a lot of issues coming from the Rust language itself, and how you handle it, and your business logic. But for your business logic, I mean, this is pretty hard to explain. So we will focus on the Rust language issues. So integer overflows in Rust by default on the release mode of Rust. The integers will just wrap up, so they will not crash. It will not panic on overflows. This is a wraparound default value, default behavior, and you can fix it through several ways. You can just overwrite the default behavior in release mode by saying that you want all the overflow to be checked. And if that's the case, it will panic on overflows and underflows. Or you can use the checked versions of operators. So you will have checked add, checked sub, checked div, and check multiplication. And these functions will return an error, a result, and if it's failing, it will return an error, and you are likely to just propagate it because, yeah, the operation just failed. And about integer downcasting, so you have to know that when you fix overflows, it does not fix downcasting. Even if you set the overflow checks in the cargo.toml, you may be prone to issues with the downcasting. So we see a lot the as keyword to be used in the wild. This keyword is really good, and you can use it when you are upcasting. So going from U64 to U128, for example. But when you are going through the opposite way, the as keyword will just silently truncate the most significant bits. So if you have something that is more than U64 max in this specific example, it will just truncate it, take the lower bits, and going on with that. So yeah, this is pretty tricky, and you should go with try into or try from, depending on how you handle the thing, instead of the as keyword. It will once again return a result when your downcasting is failing. And then you just use the question mark to propagate the error. And yeah, finally, we are going through an example of a real-world hack. So that was the cache AO exploit. It led to a 48 million loss. So that was the announcement on their Twitter account. Sam CZson just said he did an analysis of the exploit. We are not going to see it today, but we will just see how it has been done. And yeah, the thing is that Cache.io didn't establish a root of trust for all the accounts, meaning that basically they did not constrain everything in it. And yeah, the attacker was just able to crush their stablecoin. So how it was handled is that, yeah, so the functionality first, there was a print cache instruction that allowed to deposit funds and get some sort of stablecoin, which was named cash. And it was just this print cache instruction was minting crate tokens that are associated to a bank. However, the attacker was able to just, because the crate mint was not checked properly, he was able to create its own bank and using the crate mint of another bank. And so this was the fix on the GitHub of cache.io. Sorry, sorry, there is a lot of things going on in the chat. I just finished that. So yeah, that was the fix. So this shows that if you have a small constraint that is not well handled, you can go through a lot of trouble, just like a 15 million loss. And this is pretty bad, yeah. So there was some question. Someone is saying that Anchor did not actually check if the token program is a real token program when they... Okay. Do not hesitate to just take the lead and speak if you want. And so, yeah, we are done with the presentation, and this is the time for question and answers.
Yeah, and Kama.
Yeah, hey, Zigtur. So my question is more of a practical nature. So I believe you have experience, like lots of experience in coding native Solana programs. So I want to ask, since from what you have been saying so far, I realize what you mean by Anchor is a good framework because it's basically abstracts a lot of these things away. But if we are ever coding native Anchor programs, do you have any, from your experience, do you have any way that you can sort of keep in mind all the checks and constraints you need to make? Because let's say you're dealing with a code base that is, I don't know, thousands of lines long, there's always a possibility that somewhere in between you could make a small mistake that can lead to a vulnerability. So I wanted to ask, based on your experience, how do you keep this, how do you like go about ensuring that code you have is safe?
Yeah, so when you are going native Rust in Solana, it is pretty hard to be sure that you have checked everything. Even if you are using Anchor, you may have missed something. So what I would recommend is to really test a lot. I know it is a pain in Solana. Testing is pretty hard, and yeah, the tools are not enough today to be sure that you are checking everything. It's really bad to use, to be honest. So I don't have a good, yeah. I mean, having peer reviews with some other developers on your code, going through audits is a good way to be sure that your code is secure, or not be sure, but increase the level of testing. Yeah, you can use fuzz testing also, but I did not see fuzz testing on account constraints. Maybe I missed something. I'm not using fuzzing that much, to be honest. So yeah, when you are going native, I would really recommend you to be careful on what you are doing and ask for reviews from other people in your team. Yeah, I hope it answers to your question. Does static analyzers help? I did not see any tool that is doing that in Solana. Maybe there is, but yeah, like the tooling on Solana is pretty small, and you don't have a lot of tools to do it, to be honest. Next.
All right. I got a question.
Yeah.
Hey, thanks for coming in. I really appreciate you sharing this very valuable information. My question is actually related to more of the VM, because like you mentioned, you have to have a solid understanding of the VM to really know what's going on when it comes to security in smart contracts. Do you, at Cantina and SpearDAO, do you actually do you have testing strategies that you run for specifically targeting the runtime, compilers, and the VM to actually identify vulnerabilities and securities within the VM?
Like within the VM itself?
Yeah, not just at the smart contract level, but within the VM itself.
Yeah, I did not work on it, but I guess it is done by the Solana Foundation on the Solana node. Now there is Fire Dancer too. Samarash wants to answer that maybe, or she has a question.
No question, but I was just going to jump in and say, while we haven't done it for like Solana VM, as far as I know, in like similar circumstances in other ecosystems, our researchers, like, for example, if they're looking into a particular project, but they like, and Zigtur can probably speak to this better, but they usually like branch out and look at the like more high level stuff as well. And if they find something in there, they'll raise it as well. So it's not kind of just limited always to the scope of the code base put forward.
Yeah, so we can do it, but I did not personally do it, and I guess it has been done on other virtual machine, but I'm not sure it has been done on Solana by Spearbit.
Oh, okay. Because I was actually trying to figure out how they sort of run adversarial testing, like simulating attacks that focusing on the runtime's ability to actually handle unexpected behaviors and malicious inputs. It's something that is an information that is not really out there. And since you guys don't do it in Cantina, I guess I'll just keep my fingers crossed. Thank you.
I have a question about the attack that, I mean, when there were like 50 million lost, did you recover any?
No, I guess they did not recover. I went through their GitHub, and like their last tweet was just after, was almost the announcement. So I guess they did not, the project failed after that.
Let's see. So it's not possible to do something like on Ethereum when they received that attack and they had to.
So I'm not sure that I understood the question.
They have an attack on Ethereum where they've lost a lot, and I think they, I don't remember what they've done to recover some of the money.
Oh yeah, so you should. I guess you are talking about the DAO hack that happened in 2016. Yeah, they just rolled back to the block at which the exploit was done, and then they removed this transaction. It was a 160 million loss, if I remember correctly, and it has led to a fork in the chain. So this is how we have seen Ethereum without this exploit, and then Ethereum Classic with this exploit happening.
Yeah.
But since then, it has evolved a lot, and this is the only time, it was the first time that it happened, and it was the only one, because we have seen 600 million loss on Axie Infinity on Ethereum, and it doesn't be reverting this way. It was in 2020 or something like that. So yeah, I guess it will not happen again on Ethereum. But yeah, I did not see anything like that on Solana.
Thank you.
And yeah, about the fact that they just died after and funds were not recovered. It's You may have heard about the Kyber swap exploit. Also, it was like a 50 million loss and less than a year ago. I mean, today it's pretty hard. And if your project have been exploited in this way, good luck. Good luck. Any other question?
Yeah.
Yeah.
Just gonna throw in real quick. Thanks for the presentation. It was awesome. You were talking about Anchor a lot, and I have a few questions. So, for example, what I mentioned in the chat as well, that token program, there was once, I think it was like 2 years ago, when you could define the token program in your account struct, but then behind the scenes it was actually not checked if it's a real token program. So considering this and all the possible things that could happen using Anchor, what would you say? How can the developer make sure that he can avoid falling into these things? Like, for example, the token program is not being checked. Would you say expand your Anchor program every single time, and then considering that, for example, a simple escrow program would expand to like 5,000-6,000 lines of native Rust code? Or how would you go for that?
Yeah, to be honest, I'm not sure it is it is a responsibility of the developer at the end, but it should not be. I guess Anchor should do something to maybe having some sort of automatized security analysis, like doing fuzzing on their side and things like that. But yeah, it's really hard for a developer, especially when you are focused on building. If you need to understand everything about Anchor because you are building on, I mean, it requires so much knowledge that maybe going native Rust will be just more efficient at the end. So at least in native Rust, you will be sure of what you are doing. So this is a pro and cons of Anchor. It's a pros because you don't have to know how it works, but as you don't know how it works, there may be some pitfalls and you will just be vulnerable to it.
And that's why you need auditors, right?
Huh? Sorry?
And that's why you need security auditors.
Yeah, that's why I'm
check it for you. Okay, a real quick question, because we are really close to the end. I want to be respectful. As a security researcher and auditor, what would you say if you would see a native Rust contract using pointers and unsafe Rust? What would be your impression?
Yeah, this is pretty funny because I was talking about C program in Solana 1 day ago.
All right.
So yeah, that would be pretty much the same. I mean, you have Rust, which is secure by design. So just use it and don't go YOLO with unsafe Rust or C programs. But if you really want to do it, then for sure you will need. You can use fuzzing for it because you will find buffer overflows and things like that easily with fuzzing. But yeah, you will need a security review for that.
Yeah, I mean, look, unsafe Rust is basically C.
Yeah.
Yeah, there's a lot of people in the room that are chuckling under their breath now because they just did a month of building Solana programs without the actual Solana program using Pinocchio. So there's, they're all, we live on the edge a little bit. We'll worry about security later, or we'll get in touch with you guys to give you a headache.
Thanks.
Thanks, Bert. Thank you guys so much. This was great. And, really appreciate it. Berg, that was a great question. I was going to go there, but glad you did. Thank you. Really appreciate the presentation. Great talk, great content. Samara, Zigtur, really, really appreciate the time today. Everybody else, appreciate you taking the time. We are going to turn this into a video, and I'll send it over to the Cantina folks to give it a once over to make sure it captures everything that they want. And we'll get you guys back in here again. We'll do this again. This was great.
Perfect.
Thanks, y'all. We'll see you tomorrow. Is Neodyme, which is a more native Solana OG security firm. So we'll see you all then. Have a great day.
Thank you very much. Have a great day, guys. Thank you.